So if we want to take the derivative of such a function h of x, over here, the best way to go about this would be to use the quotient rule, since we know how to take the derivative of the numerator and also the bottom as well. Now over here, as usual, we're just going to say that the top is f of x, so oops, hang on, there's my pencil. Here we go. So we're going to let, wrong color, let f of x equal to 3e 2 to the x and g of x equal to square root 2 minus 5x squared. Now of course this means that h of x is actually just the quotient of these two. It's f over g. Okay. So now that we know what we're working with, we can use the quotient rule to help us out. So the quotient rule, just to recap, is h dash, and we have to derive our numerator first, so f dash multiplied by g, left alone, subtracted by, now f is left alone, and we have to take the derivative of g, and we have to divide by square of g as well. It's quite long, but the process is quite simple as long as we follow each of these terms one by one. So just to start off, we're going to have h dash equal to the derivative of our numerator f dash. Now f dash up here we know is 3e to the 2x. So what we're going to do here is we know the derivative of 3e to the 2x is it's going to be 6 at the front because we're going to bring the derivative of 2x to the front. So 6e, so we keep the base and we also keep the index as well when we derive an exponential. And we want to keep g of x the same as it is. So we're going to keep it. Now just note that we're going to turn this into index form. So turning this into index form will give us 2 minus 5x squared to the power of half. Doing this because we're going to need the derivative of this later. So I'm going to multiply by just that, 2 minus 5x to the power of half. I'm going to subtract this by the product of f. F is 3e to the 2x multiplied by the derivative of g, and this is why we have this in index form over here. So multiplied by the derivative of this, so we're going to need to use the chain rule here. So if we treat this as, let's say, the inside is u, so you can have u to the power of half. Taking the derivative of this with respect to u is going to give us half u, but that's 2 minus 5x squared to the power of not half anymore, minus 1, sorry, half minus 1. It's going to give us negative half. I'll just scroll down a bit. And continuing with the chain rule over here, since we made the substitution that use 2 minus 5x squared, we're going to need to multiply this by the derivative of this substitution, the u dx. So I'm just going to continue on just underneath, multiplied by negative 10x. Close my big brackets. Okay. So over here, we're just going to simplify a little bit. So actually, no, we can't simplify yet, of course. We haven't even finished our quotient rule. So all of this is going to be divided by g to the power of 2. So g of x is this one over here, 2 minus 5x squared square root. But of course, since we're just squaring a square root, then you're just left with 2 minus 5x squared. Okay, and now we can do a bit of simplification. So I'll just scroll up a little bit just so we can see the index in the top right here. Now what we're going to do first is take out a common factor of 3e to the 2x from both terms. It's quite clear. So let's just start with that. Now, if you take a factor of 3e to the 2x out of the first term over here, so when I say the first term, I'm looking at all of this, then this means that I'm going to be left with 2 at the front here. So 2 multiplied by 2 minus 5x to the power of half. Oh, wait. And over here, taking 3e to the 2x from this one over here means that I'm going to be left with negative 1. So minus 1 of all of this, and all of this is, well, you're going to have half times negative 10x. So hang on a sec. Let's just make sure that we can make a double negative here. So this negative here turns positive because of this negative that's multiplied by. So just make this negative sign positive. And so if this is 1 over here, so what's underlined in blue is factorized as 1. Since we took out 3e to the 2x, we're going to be left with half times 10x, which is 5x. And after that, we're left with 2 minus 5x squared to the power of half. Actually, now that I write that down, it seems like I was missing a small detail here, and that was the square over here. So sorry about that. And down here as well. So these should all be the same inside the bracket. Okay. There we go. That's a better 2. And from here, we can close the bracket. We've finished factorizing. Well, we've finished factorizing the 3e to the 2x at least. And this is all going to be over 2 minus 5x squared. Okay. So the trick here is that we can recognize that there's 2 minus 5x squared occurring in quite a few places. Oh, this was to the power of negative half. Okay. Quite a few things we're forgetting there. So just be very careful with your algebra as you do something like this, especially when you're, well, simplifying by hand. Now, since they all have 2 minus 5x squared in common, just with a different index, what we're going to do is, let's treat this as 2 minus 5x squared to the power of 1. Now, if you do this over here, then you can actually get rid of one of these 2 minus 5x squared terms because you've got a negative index here. That's quite tricky to work with. Negative index means that you're going to end up with some sort of fraction over here with this term. And that's not what you want. You want to be able to just cross this out. And to do that, you're going to need to multiply by 2 minus 5x squared to the power of half. If you do this, then this half over here, using your index laws, if you multiply this in blue with this bracket term that I just crossed out, it means that you just add the indices together when you multiply these two together. So I'm going to multiply the top and bottom of my fraction by 2 minus 5x squared. So what you do to the top, you must do at the bottom, just so you end up with the same, or not the same expression, but an equivalent expression. And if you do this, then the top will become 3e to the 2x, 2 multiplied by 2 minus 5x squared. And since we multiplied the whole numerator by 2 minus 5x squared to the power of half, then that means that this half over here is no longer half. Now it becomes half plus half. So this gives us 1. Okay. So just to clarify over here, this comes from the fact that we have half plus half. And this 5x over here is just 2 minus 5x squared multiplied by, or not multiplied by, 2 minus 5x squared to the power of 0. Because what you have here is an index of half minus half. So we're going to leave it like that. And at the bottom, what you're going to end up with is, now you need to multiply by the same thing again, 2 minus 5x squared to the power of half. So 1 plus half is going to be 3 on 2. So again, this comes from the fact that we have 1 plus half. We're just adding the indices from over here and from over here. And they're going to be added together to give you an index of 3 on 2. So I mean, it seems like a lot of work for simplification, and it still looks quite messy. But sometimes it is easier to work with as long as you have less of these complicated looking brackets. So when I say complicated looking brackets, I mean 2 minus 5x squared to the power of something. In this case over here, you have 1 to the power of 1. You don't really need this to the power of 1. You can just really scribble it out if you want. And the only complicated bracket with the only bracket with a complicated index is the one which is 3 to the power. I'll say that again. The only complicated looking bracket over here is the one at the bottom that is the power of 3 on 2. And this frees up the numerator a little bit in terms of how you can interpret it, because it is in a more simple and factorized form. So I hope that helps you out.